I usually end my lectures talking about boomerangs. And boomerangs are essentially wings that also have moment of inertia. Now, these shaped boomerangs are difficult to analyse because they don't have much in the way of symmetry. They just have one axis of symmetry. But if you were to strap two boomerangs back to back like this, then you begin to see a bit more symmetry, and I have made some boomerangs like this, which are really very symmetric. So you know exactly where the centre of mass is, and you can really begin to understand these quite well. Now, if you spin a boomerang and you throw it forwards, then what happens is the middle of the boomerang moves at a certain speed, but because of the spin, the top of the boomerang moves faster through the air, and the bottom of the boomerang moves slower because you've got forward motion and spin together. The top of the boomerang generates more aerodynamic lift as it moves through the air, so you have more force on the top of the boomerang than on the bottom. Therefore you have a twisting moment or couple, which is at right angles to the spin, precisely what we had here. A torque at right angles to the spin. That means when you throw the boomerang, you expect the boomerang to come back. I can do better than that. That's better. And that's always a good way to end the lecture. I then have smaller boomerangs, which anybody can make. This one here, and in fact this is the subject of the boomerang making day at the Grantham Gravity Fields Festival on Sunday. And these little boomerangs, I can do better than that too. And these little boomerangs come back quite nicely. That is a nice way to end the lecture because they kind of find it quite impressive that you can throw boomerangs indoors and that they actually come back.